Hello everyone, welcome to Explore Hop. For this example, we're told to determine all the discontinuities of this function, which is the function f of x is equal to x squared minus 2x minus 3 over x squared minus 5x plus 4. Let's first start by factoring the numerator and the denominator to make it easier to identify any points of discontinuity. So f of x is equal to x plus 1 times x minus 3 over x minus 1 times x minus 4. Notice how we can't divide out any terms. This means that there are no removable discontinuities. So there is a vertical asymptote at x equals 1 and x equals 4. So there is a vertical asymptote at x equals 1 and x equals 4. Now, let's show that there is a vertical asymptote at one of these values using limits. Let's do it for x equals 1. So for x equals 1, we will find the one-sided limits as x approaches 1. So the limit as x approaches 1 from the left in the function is equal to the limit as x approaches 1 from the left in the function x plus 1 times x minus 3 over x minus 1 times x minus 4. Since x is approaching 1 from the left, then we can try subbing a number a little less than 1. So if we sub in x equals 0.99, then we get 0.99 plus 1 times 0.99 minus 3 over 0.99 minus 1 times 0.99 minus 4. And this is equal to negative 3.9999 over 0.0301, which is less than 0. So this indicates that the limit as x approaches 1 from the left goes to negative infinity. So this limit is equal to negative infinity. Likewise, we can also find the limit as x approaches 1 from the right in the function f of x. Which again is equal to the limit as x approaches 1 from the right in the function x plus 1 times x minus 3 over x minus 1 times x minus 4. And this time, since we're approaching 1 from the right, then we can sub in a number larger than 1. So we can sub in x equals 1.01, for example. If we sub in x equals 1.01, we get 1.01 plus 1 times 1.01 minus 3 over 1.01 minus 1 times 1.01 minus 4. And this is equal to negative 3.999 9 over negative 0.0299. And this is greater than 0. So this indicates that the limit as x approaches 1 from the right goes to positive infinity. So this limit is equal to positive infinity. These limits show that there clearly is a vertical asymptote at x equals 1. And we could have also done the same thing for x equals 4. So here's what the graph of the function looks like. Notice that our limits are correct. We can see that as x approaches 1 from the left, f of x approaches negative infinity. And as x approaches 1 from the right, f of x approaches positive infinity. And from the graph, we can also see that as x approaches 4 from the left, f of x approaches negative infinity. And as x approaches 4 from the right, f of x approaches positive infinity. So therefore, the function has two vertical asymptotes, one at x equals 1 and one at x equals 4. And that's it for this example. Thank you for joining us. See you in the next lesson.